Hey again, everybody. Another video. In this one, I want to talk about some opcode stuff. How an opcode goes from the server to the client and then around to the various parts in the client who want to know when certain opcodes come in and what they do. We could even go the other way, requests from the client to the server. But in sort of introducing this, I need to chase down a bug, opcode related bug, so it would be a good exercise. So let's just dive right into it. I noticed this bug in one of the other videos. If I set this guy's life to say 50%, you notice this track window updated, but the target one didn't. If I click him again, then it updates. So there's something that this track window is getting that the target window is not. So let's see if we can figure out what that is. I'm going to turn the opcode logs on. So let's do, again, set life 100. So we get 3 opcodes. One that says this entity has 100 hit points. That could be it. Another basic one about position, a lot of other stuff. There's again another info about % hit points, and then some plain console text. Since set life is more of a debug tool, it spits up this this message here. So it's one of these two, hit point basic or info 1, that this track window is getting, but the target window is not. Or either the target window is getting it and is not handling it properly. So let's have a look at wind target. So we've talked about sort of the structure of this of these classes. Wind target, here's our construct, all our methods. The construct gets called, and then things happen. So in the construct, we make our J window. We don't need to talk about that. I've already talked about all this stuff. This is where various classes and components can hook into the opcode system. Now, it's called register WebSocket route. That's simply an artifact of the way it was done before when this was all WebSocket based. You could change that. I could, search and replace and change this easy enough, but that's pointless at this point, or not relevant at this point. So I'm registering in this class construct that whenever opInfoEntity1 comes through, we should call this function and handle it. So there's opInfo1, and what was the other one? HP basic. So we have handlers for both. So okay, the mystery deepens. So let's see what's going on in info1. So when the opcode comes in, when this function gets called, all opcode responding functions are passed an object. And I generally call this object the map. What it is so when an opcode comes in over the wire, it's just pipe delimited stuff like this. It's not, binary packet structure stuff. It comes in pipe separated. It could convert this subsystem to a more data structured thing in the future. But for now, it's easy to deal with just pipe stuff. I can just look at it from the debug lines and fix stuff there. But anyway, this all gets separated by pipes and then turned into an object where each of these values is broken out with name value pairs. So it's pretty straightforward. 3047 was the opcode, and then as it gets turned into an object, this is just a JSON blob dump. Here are all the properties left to right of what came in. So that is what this map object, this map parameter that comes in is. So I say if I currently don't, if this win target currently doesn't have anything sort of bookmarked as its target entity, then return false. Now that's interesting because normally if this w.target entity is sort of a class property that conventionally I normally would do, I would define it up here so that I know down here I'm using it. So the fact that it's not up here is suspicious. So we'll keep that in mind, but we'll proceed. If map entity ID equals my target ID, then set %. Okay, so let's see where else this is or isn't being used. So on target entity. Okay, so let's check this out. This is probably the deal. So when my target changes, I'm going to click on myself here, press F1, ignore this error. This has something to do with this Path Manager window. I get the opcode that my target changed to this entity ID, and it conveniently sends me % hit points, but not relevant for now. I got the opcode that the target entity changed, and of course this target window wants to know that. So one of its hooks is on info target entity, all this function, and we do some cosmetic things. We update, this label with the entity name, and we set the hit point bar. But we never did anything with this w.target entity. So that's probably what's going on here. This value is not being set when the target changes. I think I moved this concept of the target out of target window into the game. So yeah, game current target. Let's see what that is. Right, yeah. Right, alrighty. So we should probably use that. That's probably what was going on. I might have been eliminating this w.target entity from this class and using just the game's target tracking. So that's probably what's going on. So instead of w.target entity, it's going to be if, do I have reference to game up here? I don't, but that's fine. Game is a global thing at this point. So if game.current target is undefined, return false. Current target just to be undefined. I'm going to see what happens when we clear a target, make sure it gets set back to undefined. So if you're back in the game, on info entity target, oh, here we go, target clear. Oops. Yeah, okay, so we cleared it out. So we can count on that to be current. And here again, we can change this reference, game current target UID, and let's see if this target entity has been left around anywhere else, which it has. Just again, it's going to be game.current target. Let's keep going. There's lots of them. Wait, what was that? Oh yeah, target, that's fine. Man, I must have been in the middle of changing this or just getting going on changing it. I should probably search and replace, but I sometimes feel safer just doing these all manually. Alright, I think we're ready to go. Let's give this bad boy a run. Alright, let's do set life 50. Boom. Okay, they both changed. Now I noticed in the video the instance was when I was healing somebody. So there's a small little regen. Yeah, okay, they're both updating. Looks good now. Alright, so there we go, bug fixed. But let's step back and look at that opcode system I was telling you about. So opcodes. So the config, most of the config of this game is database driven. And that's obviously intentional. Databases make good sort of configuration repositories. So as opcodes are created for the game, they're usually added here into this opcode SQL, which gets reloaded if I add a new one. Remember that map thing I was telling you about? That's the second column. So an opcode gets an ID, an auto-generated ID, and part of its other definition is the parameters related to it. Now, let's have a look in the database at what this looks like. So pretty much just like you'd expect. I just showed you the SQL, so of course it's going to look just like that. 132 current opcodes. Some here that I haven't implemented yet. Actually, these aren't necessarily actual event-driven opcodes. Sometimes an opcode can be descriptive in nature. For example, one of these opcodes is like your cast was prevented, and another opcode will be sort of the reason behind it. So you might get, you know, a data packet in the front end where your opcode is that your spell was prevented. And I'm just going to turn off these because he's going to keep ticking because he's getting healed. An opcode that says your cast was prevented, and then another reason code, which it's just a unique identifier of like this. These are almost like constants more than opcodes at this point. These could get phased out. I do have a game constants table. Where you can sort of tweak the behavior of some aspects of the game. So the effort behind this opcode system was that I wanted one central place to define the opcodes, and the front end and the back end need to know about them equally. So how is that done? So if it's in the database, it's fairly easy for PHP to get this stuff. I mean, fairly easy for either side to get this stuff. But these all essentially need to be translated or sent up to the front end in some manner, either as like, I don't know, I don't want to say constants because they're more than just a name value pair, but let me just show you what actually happens. If you remember in one of the previous videos, we used this MGR utility. I'll hit rebuild all so I can get the message. So, processing package JSON, index, HTML parts. I wanted to reintegrate opcodes, not do the other one. So, reintegrating opcodes. Imports the opcodes SQL into MySQL, or in this case, it's actually MariaDB, it's not MySQL. And then regenerating constants.js. Let's have a look at that file. So, the UI, part of the package JSON in the UI, is reading in this constants.js file. So this constants.js file automatically generated via, I believe this is, it spits out JavaScript code, but it's a PHP script that dumps this all out. And I'll show you that in a minute. So everything in the database gets generated into this opcode, constants.json for convenient use in the UI. For example, I can say all skills by ID, and I immediately have access to the whole dictionary of various skills, their IDs. And this is a simple one. It's just ID and name. Let's see if there's something a little more verbose here. And I do lookups and sort of reverse lookups. So a name gets you an ID, and then the other way around, ID gets you a name. Let's see. How about all opcodes by ID? That's a big one. That's obviously got all the opcodes in here, and I can even show you the map. So it automatically interprets for each opcode the parameters that go with it. And then there are JavaScript functions that when an opcode comes into the UI, that pipe delimited string gets integrated into these in their order. So nothing too complicated there for the front end to get it. Back end is Not too much worse. If I bring up, I think I have an includes file. Zone server. Okay, so zone server, which is the main process hosting this zone, it's got a requires file. So basically, everything in the game gets pulled into this zone process. But one of them is constants PHP. Let's look that up. So a couple just static lookup classes. These are hard-coded right now. I don't know if that'll change, but the constants import. This is what I wanted to have a look at. This is a class that will look at a database table, and given a couple other hints about which columns you're interested in, it will actually generate the define statements. So if you know PHP, normally you would do like define my const. Actually, I think these are quoted. My const 1, 2, 3, and then anywhere else in the program, you can do stuff like that. So this is just dynamic const generation, so that all I have to do is mess with the database, and then I immediately have access. Or once I rebuild, actually I don't even need to rebuild OpCodes, do I? Yeah, I think I do. Yeah. Yeah, if I mess with anything really in the database, I just need to come in here and reintegrate the OpCodes to get this new constants.js. But anyway, tweaking the database gets those changes to both the front end and the back end pretty quickly, so there's not a lot of duplication of effort. So that's how OpCodes are defined. I talked briefly, let's go back to the front end again for a second. I walked over briefly this register WebSocket route before. That is really the main guts of how OpCodes get passed around the system. Fairly simple concept, really. Each class just registers what they're interested in and the callback function for it. Now, order matters here. When this game class starts, this game class is what's responsible for making a lot of the game components, the buff window, the track window, target window, this self window. These are all created by this game class, and those are created after the game class gets a first stab. So the game class is generally going to be the first class to see any opcode that comes in. And that is important because what this game class does some of the time is, for example, on this target entity, whenever a target changes in the game, opcode is sent to the client. The game class gets it first because the game class wants to be in control of managing this current target variable, and that makes sense because the track window doesn't manage its own target. It relies on game.currentTarget to be accurate and current. So by the time a hit point detail packet comes in, that was probably a bad example. We're in the track window. By the time a hit point detail packet comes in, it's expecting this game.currentTarget to be active and correct. So just keep that in mind when you see how I register these. Just remember that order matters. There's sort of a hierarchy of who's hooked into this system. Now, all register WebSocket route is doing is just managing an array of opcodes, and I call them categories, and the callback function. I mean, it's really nothing here of much consequence, but it's pretty quick. I mean, it's just it's again an associative array, quick lookup. But let's open it up another window. How about the effects window? And again, we've gone through the structure. Don't need to do that again. But generally, what's going on is in the construct, the window is hooking into. Hold on. Sorry about that interruption. So we were talking about just sort of going over another example of windows hooking into, or classes hooking into their relevant opcodes. This one is pretty simple. Really only cares about when effects are added and removed. Not too much here. Let's talk about the op controller classes. So the sending of codes, either the client making a request to the backend or vice versa. Each one has what I call an op controller class, responsible for actually doing the conversion of the request into the appropriate opcode structure. You know, opcode pipe this, pipe that, pipe whatever. And then of course sending it off. Turn this thing off again. So let's find an example of a window or something actually sending sending a packet to the backend. So if let's see. Okay, so it looks like here. That this WinTarget class is actually the one responsible for managing when in the front end, when I hit like F1 to target myself or click on that dude, it's actually the one sending the out command. I would have thought I would have put that in the game class, but let's roll with it. So on the key combo action, there's a whole other key binding system in here that we can talk about at some point. This was a bit of an undertaking, but I think it turned out all right. Let's see, target self F1, just as an example. I can bring this up and let's put it on something. How about F2? Accept that, and let's see if I'm doing F1 now, nothing's happening. Here we go, F2. But whatever. So when the key combo gets triggered, and let's just jump in right here. We won't cover how all this works up to this point. We're only interested in what's happening here at the send command. So opcontroller send command, and since the front end knows about the opcode constants, I can go ahead and use them. And the only parameter to that one is the UID of the entity I would like to target. Now again, remember these are just requests, so I prefix these particular opcodes with oprec, so that I know that they're not authoritative, they're not orders, they're requests. If I look in the opcodes SQL, I've put client to zone direction servers in their own opcode range, and they all start with request because they could be denied. The zone server can obviously needs to sanity check everything that comes in. You know, if I'm targeting some entity that doesn't exist, or I'm targeting something that shouldn't be targeted or can't be targeted, and of course I need to turn that down. So let's have a quick look at, let's follow the path here of opcontroller send command. So here we are. Send command takes opcode params prefix. Prefix of the squiggly prefix was a convention I was using or am using. Let me turn it back on. You see all of these have a squiggly on the beginning. Let me see if I can find one. Don't know if I can give an example of the other type, or at least I can't show it. The squiggly means that you're going from client to zone server. There's another one, I think it's a hash symbol that means you're going from client to the zone mesh server. Because those movement, so these are movement requests, which means maybe I have that backwards. No. And I'm a little unclear on how exactly that was, but anyway, it's just a hint on sort of the destination of the opcode, if I recall correctly. So send command. So OC messenger. What is OC messenger? Messenger is a class that gets passed to OpController when you're making a new OpController. So let's chase that down. I believe that might be in startup. Nope. How about main? Yes, right here. So this is sort of dipping back into Electron framework a little bit. Electron has the concept of your render process and the, what's the verbology for it? I want to say like kind of more of like the back-end actual node process. You know, even though this is, you know, Electron framework, you know, I've got the console open here in the UI. I've got access to all my JavaScript. I can't just like start doing like socket stuff here on this website, but I mean like the lower level OS stuff. You know, I can't open a file right from JavaScript here in this web interface. There's a separation layer where this layer here, the surface level front end stuff, needs to talk to. Think of it as like this is the Electron output window here. Think of this as kind of like a pseudo backend portion of it, and this is what can actually do the reading of reading and writing of files. It can open your your network sockets and things like that. That's where you get your UDP access and whatnot. But there's a communication mechanism required between, like I said, this surface level JavaScript and the lower level Electron engine, or technically node portion of Electron, and that's done via a communicator. I call it renderer communicator because it's a message. You're messaging from the renderer, which is the surface level JavaScript, to I use the verbology here of main, sort of the main process. But you have to send these messages back and forth, which not the worst thing in the world. It just adds a layer of communication that you have to manage. So that was like, hurdle number one, implementing. And I think the Chrome application framework was the same way. You had your surface level JavaScript, and then you had the Chrome app deeper layer, which gave you access to the client's client system, some local storage things there. Been a while back. I don't remember exactly everything it gave you access to, but that's how you got to socket stuff in Chrome apps. So just keep that in mind. But Messenger is a class that actually does the socket opening and the socket sending and things of that nature. It's all this asynchronous callback stuff. So when I instantiate an OpController, I want the OpController to make its actual send requests to this class. Now I could just probably integrate this into OpController, but I actually use that same OpController JS on the Zone Mesh server for a completely different purpose, and it needs a version of Messenger, right? The Messenger parameter that it gets from instantiation it has its slightly different requirements for operating in a node environment versus this Electron environment. So that's why Messenger is sort of a pluggable thing here. But that's OpController, that's send command. So Messenger post message. We'll take a quick look at that. Follow that code path. Messenger. Post message. Oh. Why is that not? Should there not be a post message in here? Let me chase this down. I might have this messenger might only be for this lower level. Yeah. Yeah. Okay. So this messenger I showed you actually wasn't the messenger. It's getting passed into OpController because this is a surface level layer. This is the lower level layer. I'm guessing. Let's see. Here we go. It was in game.js. Big shocker. Here we go. Messenger, post message. Post message async. And this is, like I said, that communication layer between the renderer and that lower level. So this message to render from main, this is how the lower level, when it gets an incoming message from the game, broadcasts to the front end, and this is where, or that surface level layer I keep referring to, and that's actually where, remember the register WebSocket routes, this leads to that process or that function that finds applicable routes and lets them know about the opcode. IPC renderer, yeah, that's just the Electron component that lets me talk to that lower level layer. So message to server from renderer. I say server here. Really, this message is going to main, and that actually sends it to server. But nothing really ever goes to main and stays in main. So semantically, message to server from renderer, and then the data. So that's the code path of the front end sending something to the server. Let's go back into PHP land and let's see how an opcode goes from the back into the front end. So one of the includes for a zone server is called OpZone. So as I showed you earlier, there's an OpController class in PHP as well. Again, this is really just sort of your traffic manager. There's nothing, I don't think, game-specific in here. And the game-specific thing is that, you know, where it actually sends this stuff off to. Okay, so OpZone. OpZone is a class that manages the callbacks. Think of, see this OpController register code? This is similar to the front end's register WebSocket route. So the same idea here. Register awareness of when an opcode request comes in and the function handler to deal with it. A little additional stuff here required for PHP to have that same functionality, but generally it's pretty close. So this is the incoming handler. Let's, I wanted to show you how stuff goes out though. So let's look at one of our actual game classes. Like, let's go back to body, and like, you know, you take some damage or something. Yeah, so you receive some spell damage. Let's see if we can follow this path down to when we actually, yeah, okay. So when you receive spell damage, all the sanity check stuff happens. Let's say it landed your hit points get deducted. If your hit points are 0, or if you went below 0, you're now 0, which means you're going to be dead. Update your percentage of hit points, and then we send out the packet. So ops gets you back to op zone. And this has all the game-specific routes to it. So let's see what was this again. Info send spell attack result. So let's see what that looks like over in op zone. Here it is. So it's just a function, very simple function. All the details about who gave the damage, who took it. You know, was it magic damage, fire damage, you know, cold damage, whatever. Actually, no, that's the name of the class. Like the base class name of, you know, of a nuke spell or whatever it may be. School ID is the magic, fire, cold, or maybe it's that. Heck, I forget. Result code: did it land? Was it resisted? And anything in between, and then the amount of damage. So this class takes all that, fires it off to this one, because when you're standing by somebody and you get hit with a spell, everybody in the game around you is going to get a message like so-and-so was hit for 100 points of damage from so-and-so by their, you know, fire nuke or whatever the spell is called. So that's what this does. Sometimes you really only send it to the singular person, like when I turn attack on and off. I'm sorry. Oops. So I'm hitting the attack on and off button. So when attack gets turned on and off, you know, it's not like everybody around me gets a message that I turned my attack on and off. That's just a singular send to your entity, and then the detail about what happened. But this one just sends to a different function that basically iterates everybody around you and sends them the same packet of information, and they can render it appropriately. You know, if their client says, you know, if the taker is me, then when I'm rendering the text, you know, use the word you instead of so-and-so. And all that logic is in the front end. I just simply send up the giver and takers. We could have a quick look at that, I guess. There's a whole bunch of those. It's up towards the top here. So sent to entity proximity, and then you can exempt if you want some people around you. Yeah, that's just where you're integrating any exempts. Right now, the who I ultimately end up sending the information to is everybody in the zone. One of the challenges, one of the nuts I haven't cracked yet is quickly and efficiently figuring out who all is in range, you know, who all is within 100 feet of me or 500 feet of me, and only those people are close enough to actually warrant receiving this message, because obviously you're not going to get, you know, so-and-so hit so-and-so for 5 points of damage when they're, you know, halfway across the zone and you can't even see them and be pointless. Yeah, so for now I'm sending it to everything in the zone, every person in the zone. The entity needs to be played by a person before I even bother sending the message. So that's send to proximity, but ultimately, yeah, it ends up sending it to itself, or sending it to that individual client. Take a quick look at the send as well. Same thing, op controller send. By this point, the pipe delimited opcode structure is created. If I recall correctly, this actually maybe it's not. Let's have a quick look. Op controller send. Yeah, okay, it happens here. It gets imploded down by pipe, prefixed with that, and then actually put onto the socket, or sent into the socket. So to recap again, OpZone is a class populated with relevant hooks and functions specific to the class that included it. I have another one, ops login server. Okay, so login server. This I remember earlier saying that this was WebSocket based. It apparently also has some UDP communications to it. Oh yeah, so it's WebSocket from the client to the login server, and then once the login server validates people, it needs to communicate to the zone processes about expect so and so to come knocking on your IP and port, asking to come into your zone. It's good. I've authenticated and blah blah blah. So it's got sort of some dual things going on here. But again, this ops login server only hooks into the ops it cares about and has the relevant functions with it. Ops world server, again, same thing. World server, I haven't talked much about this architecture. World servers launch login servers, and world servers also launch so world servers launch login servers and zones. So there's really just a one-tier thing. Make sure I covered everything properly. Logins. Yeah. So when you see when I start the game, I basically start a world server. And stuff flies by, but yeah. So it launches a login server, launches a zone server. Yeah, so fairly simple setup there. I could talk more at some point again about how that that sort of permission granting system works when you've authenticated to the login server, and then it tells the zone servers to expect entry. Your login states, I'll divert here for just a minute. Even the account logins and states, I believe I'm tracking in a table here. Yeah, so zone movement, zone processes. Yeah. So let's start the game. What's that? Already in use. All right, I've been starting and stopping this stuff too much. Let me make sure I get it all cleaned up. Ooh, yeah. And we've still got a few going. Let's see what happens here. Kill them all. Go, and no errors. Okay, so BG that. Get back into the database. So when I started the world server, it identified that it needed to fire up this zone here. This is the only zone that's enabled. Points at the zone obj file. This is for the nav mesh server for pathfinding. So it's gonna, yeah, I guess I left that out of the startup. So world server launches the login server, the zone servers, and the zone server might actually be what starts the zone mesh server. Yeah, it does. Okay, so a zone server, or zone process will start a zone mesh server, which reads in these. And of course, they talk to each other and exchange their IPs and ports for their communication. But so we've started one zone process. That's why we've got one of these. And We know what its IP and port is, so anything else that starts up can just look in here and see what's running if it needs to talk to it for whatever reason. And then there's zone movement. This is what handles entry, and like when I hit a zone line or when I go from login server into the zone. Let's see if I can catch this in between at some point. Maybe not. It gets all glitchy when I'm recording for some reason. It's annoying. I wonder if I didn't phase that part out. Let's check. This is gonna go. I'm kind of getting into the weeds here. Add client to zone via world server. Let's see what happens. Oops. Yeah, I don't think I'm using this zone movement anymore. That was going to be how I authorize people to zone into zones, but I think what I did instead was the client can accept messages from the world server, and so when a person logs in, the login server process tells the world server, tell so and so that they're allowed now, or that they need to load up, the zone object files, and basically tell so and so's client to put them, or to expect to be in zone XYZ. And so that opcode comes in. The client's like, "Whoops, I'm supposed to be in fell width. Let me load up the fell width zone zone geometry." And at that point, the zone server will send this client information about spawn entities, anything else relevant to the zone, and the client will then, of course, render that stuff. If you could make your client load up another zone, but you can't trick the game into putting you somewhere else. The game is only going to send you data for the zone that the game knows you're in. So you can't just inherently, by the nature of this design, you can't get the game, you can't trick the game into sending you somewhere else. It's completely authoritative on the server side, based on the world server. You can ask the world server, can I go somewhere else? And it'll do its authentication mechanisms, just like what happens at login time. The login server authenticates you, looks in the database where you last logged out, or actually looks in probably your character JSON. Maybe not though. Oh yeah, no, there you are. Looks in there, and because the world server can take the word of the login server will say, world server, you can put this character in this zone, because that's what I got out of his JSON. And then the world server will look up or resolve the correct zone process, send a packet to that zone process saying, start sending zone updates to this client IP and port. I hope that makes sense. So that was a little off track. I know we were talking about opcodes in this video, and honestly I don't feel like I gave that great of an explanation of them. So if you have questions about how that all worked, leave a comment. I'll be happy to cover whatever portions were not that clear, but I'll go ahead and stop this for now.